Welcome to this explainer. You know what's crazy? Some of the absolute most powerful organizations in human history are practically invisible to us today. I mean, their names aren't printed on the devices we grab every single morning, their founders aren't massive celebrities, and their logos aren't recognized by billions of people. Yet without this one specific, quiet laboratory, the entire modern tech landscape simply wouldn't exist. Today, we're unpacking the fascinating story of Bell Laboratories, the forgotten giant that laid the absolute foundation for our modern digital world.
Okay, so let's dive right in and ask a seemingly simple question. Who actually invented the fundamental building blocks of the tech we use every single day? When we think about the digital age, our minds instantly jump straight to Silicon Valley, right? We picture the tech behemoths who sell us our phones, run our search engines, and build artificial intelligence. But the truth is, the core architecture of this entire era was largely built in a research facility in New Jersey, way before the modern tech boom was even a blip on the radar. There is this massive, glaring contrast between what we see and who actually built it. We see the highly visible modern tech landscape, the shiny smartphones, the AI, the famous CEOs, but at its peak, Bell Labs was arguably one of the most extraordinary scientific organizations ever created. Inside those walls, relatively anonymous researchers were quietly developing the core technologies that would eventually power our computers, telecommunications, satellites, and literally the entire digital economy we rely on today. But here is the wildest part of this whole story. Bell Labs, they weren't founded to build computers. They weren't thinking about the internet or artificial intelligence. They were literally just trying to solve the massive, everyday headaches of early 20th century telephone networks. Long-distance communication back then was incredibly frustrating. Signals didn't just get weaker as they traveled, they degraded into this awful mess of static. Connections dropped constantly. The networks were enormously expensive, the equipment was highly unreliable, and as more people started getting phones, the engineering challenges just became exponentially more complex. Bell Labs was created just to fix those massive telecommunication bottlenecks. So to solve these incredibly difficult problems, Bell Labs did something totally radical for the time. Instead of just focusing on quick, short-term fixes, they built a deeply unusual scientific environment. They didn't just silo people into different departments. They mashed them all together in one space. You had physicists working right alongside engineers, mathematicians chatting with chemists, materials scientists brainstorming with communication experts. They realized that the absolute greatest discoveries happen at the messy, unpredictable intersections of different disciplines. They gave these brilliant minds total freedom to investigate fundamental questions without demanding some immediate commercial payoff. And you know what? That radical, failure-tolerant environment inevitably led to an absolute bombshell of a breakthrough. The year was 1947. Before this breakthrough, electronic systems had to rely on vacuum tubes. And let me tell you, these things were a nightmare. They were fragile, power-hungry heat generators that constantly blew out and severely bottlenecked any real innovation. You simply couldn't build complex computers with them. Enter Bell Labs researchers John Bardeen, Walter Bratton, and William Shockley. While they were just searching for a better way to control phone signals, they invented the transistor. And it solved absolutely everything. It was tiny, it ran cool, it was super efficient, and infinitely scalable. It is arguably the single most important hardware invention in human history. And that tiny little invention triggered an absolutely massive chain reaction. Think of it as the ultimate example of compounding knowledge. Transistors didn't just sit in a vacuum. They became the bedrock for integrated circuits. Those integrated circuits evolved into microprocessors, which then birthed personal computers, the global internet, and eventually today's massive artificial intelligence infrastructure. That entire technological family tree, literally everything driving the modern world, grew directly from that one single laboratory in New Jersey. So thanks to the transistor, we had the hardware sorted out. Things could get smaller, they could get faster, but a brand new, huge question quickly popped up. As we build these massive global networks, how do we actually measure, manage, and transmit all of this new information? Because let's face it, hardware is entirely useless if you don't know the rules of the data flowing through it. Enter Claude Shannon. Now, Shannon was famously a bit eccentric. He was actually known to ride a unicycle while juggling through the halls of the lab, but he was also grappling with a profound problem: how information itself could be mathematically measured. Born out of this incredibly unconventional environment, Shannon developed the complete mathematical foundations of information theory. He introduced these immensely powerful concepts of bandwidth and noise, and today, those exact specific concepts sit underneath absolutely every single digital communication system on the planet. But Bell Labs wasn't even close to finished.
I mean, transistors and information theory were really just the start. Because they fostered this unique, open-ended environment, their researchers pioneered an unbelievable array of technologies. We're talking lasers, radio astronomy, satellite communications, digital switching, solar cells, advanced signal processing. Some of these birthed major global industries, while others kind of quietly disappeared. But consistently proving their model worked across so many multiple disciplines, that proved their approach to science was uniquely, undeniably powerful.
So, what was the secret sauce? The crucial takeaway here is their underlying philosophy of innovation. They deeply, fundamentally understood that a scientist might spend years on a problem without ever knowing if it'll produce a profitable product. Not every experiment had to succeed, and failure was readily accepted as just a normal, necessary part of discovery. They understood that failure wasn't wasted money, it was a stepping stone. It was how you compound knowledge and unlock brand new engineering possibilities. They weren't just building products, they were building knowledge itself. Unfortunately, well, nothing lasts forever. The economic environment that allowed this scientific utopia to thrive eventually shifted. In the 1980s, the telecommunications industry went through a massive restructuring, and Bell Labs' parent company, AT&T, was forced to break apart. The old, steady business model that funded this incredible scientific city completely vanished overnight. And while Bell Labs did survive in different forms, its legendary, fully open-ended research culture gradually began to fade away.
But this leaves us with a deeply fascinating paradox. As Bell Labs became much less powerful as a specific, centralized organization, the technologies it birthed, they became infinitely more powerful across the globe. The laboratory itself faded, but its legacy exponentially multiplied. As computing power completely exploded, and electronics became the single most important industry on Earth. To really put that staggering scale into perspective, just think about this. The phone sitting in your pocket right now is running on literally billions of direct descendants of that one 1947 invention. Billions. And it's not just our phones. The modern global data center, the massive server farms powering global finance and AI, they simply do not exist without the ideas born in that one quiet lab. It is a true exponential explosion of pure innovation. The lessons of Bell Labs matter even more today, right? Because right now, modern companies are throwing enormous amounts of capital into cutting-edge fields: artificial intelligence, advanced chip manufacturing, quantum computing, fusion energy, robotics, biotechnology. Most of these experiments, just like back at Bell Labs, will never become world-changing products. Some are going to fail completely. But they are all hoping to stumble upon a breakthrough of a similar, world-altering magnitude. But as this explainer has shown, the strange thing about true innovation is that the absolute most valuable discoveries are almost always the ones nobody actually knows how to monetize yet. The future rarely announces itself with a parade. It usually begins as a small, quiet experiment that seems important only to the incredibly focused people working on it in a room. Bell Labs' greatest achievement was simply creating the conditions where those unexpected, quiet breakthroughs were allowed to happen in the first place. Which leaves us with a profound realization about the world we're living in today. Everyone remembers the companies that sold us the future, but history so often forgets the ones that quietly invented it. So I'll leave you with this thought to ponder. As we blindly race forward into an era of AI and quantum tech, pouring billions upon billions into the next big thing, where is the next foundational breakthrough quietly happening right now? In what forgotten, quiet lab is the next transistor waiting to build our next century? Thank you for joining me for this explainer. And as always, keep questioning the world around you.